So I'm going to start with what I call Brain 101. So here's a shot of the human brain, a photograph. And this is a teacher's brain at the end of a day. Just kidding. It's a long day. Just thought I'd throw in a little humor. Let's get back to the brain. So the brain is a 3-pound universe. When we're born, we have a 1-pound brain, and the brain grows, it doubles its size in 1 year. So when we're 1 year old, we have a 2-pound brain. So you can imagine the growth that happens in our learning from infancy to 1 year old. And then it takes about 18 to 24 more years to grow to its full size of a 3-pound brain. You've probably seen these mock-ups of brain cells. So the has 3 parts, basically neurons and dendrites that come out of the main neuron of the brain cell, and then a long axon that ends in terminal points as well. So when we are thinking a thought or processing, our information comes in through our senses, our 5 senses, and then it becomes an electrical charge through a brain cell until it reaches the tips of the axon terminals, and then the information changes to a chemical neurotransmitter, and mostly the neurotransmitters tell the information to stop and not go any further. But if the thought continues on, it continues across a tiny little space and continues into the next brain cell. So we're going to get back to this in a moment. You'll see something interesting. So I'm going to give you a brain activity. And you can do this with kids. Your hand actually makes a nice model of a brain cell with the dendrites as your fingertips, the cell body as the main part of your hand, and then your arm as your axon. So you can have kids kind of show you their brain cell. Our brains are enormously powerful. We're just finding out how incredible they are. We have about 100 billion brain cells. So just take that in. But that's only part of the story. Each neuron can interface with about up to 50,000 other neurons. So that is about 1 quadrillion synapses or possible connections in the human brain. Some expert, and I don't have the quote with me right now, said there are more possible connections in the human brain than stars in the Milky Way galaxy. So it is kind of a lot. It's good to know as educators also, because every student has that much brain power in their brain. We're learning how experiences reshape our brain. And so information comes into our brain cell, but let me give you an analogy and use, again, a powerful, impactful teaching strategy. This was before GPS on your cell phones. If you ever drove in a car with a friend somewhere and you were the passenger, and then at another time you had to go to that house, that store, that place all by yourself, it was like you were never there in the first place. You were a passenger in the car and you didn't really pay much attention. So likewise, when students are passengers in our lessons, it doesn't really create the dendritic growth as when they are driving. So experiences have to be the students' active experiences, not just listening. Listening can impact the brain. Let's just say if there were an earthquake right now and someone over a loudspeaker were to give you information on how to be safe, you would process that. It would be very meaningful to you. But generally, just lecture does not create the dendritic rich branching that we know happens through experience. I'm going to actually let you look at this happening. So this is a real inside look at a brain cell connecting in a dendrite. Now you're going to see it again in slow motion. So you can see, watch this dendrite reach out, reach out, growing, 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 and it connects. So I'm going to stop that. Isn't that amazing? Isn't that just amazing to see that happening in our brain? So as I shared with you, experience only reshapes the brain when we are actively doing things. And I'm going to come back to this a little bit when we talk about memory and long-term memory. Actually, let me go back on that slide for a moment. Does that mean that we have to have we have to stand on our heads and do backflips for every lesson? Absolutely not. But sometime in the school day, in the school week, have your students engaged, doing something, thinking, working with others. It helps the brain make these connections and helps them liking themselves and liking school and wanting to be there. Okay, so I'm going to talk about how this growth in the brain is called neuroplasticity. And again, that is brain being plastic. There's some wonderful children's book, The Fantastic Plastic Brain and Bubblegum Brain, that bring this neuroplasticity idea to young children. So it occurs when the neurons in the brain branch out through the dendrites to create other neural pathways. And these neural pathways help to expand the brain's ability to retain information. And so neuroplasticity is really the foundation of this new thrust in education growth mindset. So many of you teachers and educators are working with growth mindset and having children learn the phrase, not yet. I haven't learned it. This is hard. I can't, not yet. That not yet opens up their brain emotionally to the possibility that they can learn, but it's all based on the physiology of neuroplasticity. The brain has an opportunity to keep growing. And we're also learning an interesting fact, and I didn't know this, our authors from neuroscience, failure actually helps the brain grow more than success. When we have success, we kind of go, and we move on. When we're stopped, we have to go, oh my goodness, what happened? And maybe we have some emotion around that. So that kind of makes it more memorable. And then we have to find our way around the failure or the mistake. So failure is a wonderful way for the brain to continue growing in brain plasticity. Neuroscience principle number 2, stress affects memory. Actually, if you were in the class, you know that we had a whole session on that. So this is a nice model of the inside of the brain and with particular parts. So the hippocampus is this large pink area, and right on the tip of it is the amygdala or the amygdalae. In both of these, kind of like an almond-shaped part of the brain. And let me see if I added this. Yeah, let me go back here. This amygdala is kind of like a guard and a sentry from the primal older brain, and it does not let anything happen to us that is bad. We have fight, flight, freeze mechanism from our primal brain, and the amygdala is every information that comes into the brain passes through the amygdala first. And if it's learning and we're fine and everything's just calm, the amygdala allows the information to go into the hippocampus, where it is stored as memories and then moved to higher cortical centers. But if the amygdala says, I'm stressed, I'm scared, or you know what? I'm bored. We're learning that the amygdala is active even if we are bored. So the information never gets into our memory centers or higher cortical centers. But also, we can't have, here's a little more about boredom. We can't have too little challenge. So we try to find this flow state that we have enough challenge to keep us interested, but not too much challenge where we feel threatened and we're anxious. So this is such an important part for teachers to try to find this flow state. And we can ask our students, and I've seen a lot of teachers have these little icons in the beginning of the day, and the children come in. Classroom meetings are another way to kind of keep in touch with how your students are feeling in this flow state, or just like, is this something that we need to go over? And you can never ask students, do you understand? Do you have any questions? Because they don't know what they don't know. But lots of students can kind of give you that feedback with their bodies, and you can kind of tell when they're in the flow state or when they're in their anxious moments. So it's two sides of the same coin we're learning. All of the social emotional learning, and I've seen some articles from some faction of some parent groups that are a little against social emotional learning. And I think one of the jobs that we have as educators is to share some of this learning about the brain with our parents, our partners in education, that the learning has to go through an emotional state to become part of our long-term learning. So brain principle number 3, how to make learning sticky. I like that, sticky. This is kind of old, and you may have seen this back in your undergraduate days in educational psychology or psychology, but it is the retention rate for different modes of teaching. So you can see that when you are just lecturing, and we know this because we know our own learning, we lose 95% of what we have just heard. You go out of any lecture, somebody says, oh, that was really good. Well, what did you hear? And maybe the beginning and the end we might remember, but all that in the middle is kind of forgotten. Okay, we're going to add reading. Still, we lose 90% in the retention rate. Okay, we're going to see and hear. We still learn 80%. We lose 80%. Demonstration is better, but we lose 70%. It is not until we get the students to do something back to us, make their brains work, not just input, but putting something back out, do we get anywhere near 50% and higher. So a discussion group helps students remember more. Even it's interesting, there's a bit of research on children who don't participate in a discussion group. They still remember more being in a small group, not saying anything, than they do in the large class when they're just listening to us lecture. They're getting more information in the discussion group. Practice by doing, they remember 75%. And teaching others, it's really interesting. When you teach others or you have immediate use, but teaching others, you process information in a very different way. As teachers all know, if we are not sure on some content we're teaching, if we start teaching it to the students, that's when we learn it the best of all, having gone through that many, many years. If we move to a new grade level, our new school, all of a sudden we're stuck again. And then when we teach our students, we remember it longer ourselves. So another idea, a cue to help students with their memory, help learning become sticky, is creative, useful, and emotional. So it's a CUE. So if you can, I'm going to play with you for a moment. So think about something in your past, maybe high school, middle school, elementary, that was so creative. Can you still pull it back? Can you still remember something? And when I've done this in class and I get a lot of feedback, I'm not going to take the feedback right now, but people can remember things way back in kindergarten, first grade, the primary grades, and they're usually projects that they did or field trips, something that was really creative and novel and different. And the memories just come back right like that. So let me go to emotional. I also do this, and I'm not going to actually do this with you all for the time limitations, but I ask them, I tell them I'm going to recall some learnings in your past. And if you have an emotional feeling, positive or negative, raise your hand. And so I call out learning geometry. And then people raise their hands and I go around the room, positive or negative, positive or negative. And they right away, they say positive, 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 negative, positive, positive. So learning a foreign language would be another one, positive or negative. So you can kind of think inside your head. Do you have a positive or negative reaction? Learning to drive a car, positive or negative? Learning to type, positive or negative? And what the point is that even though these were long ago, your emotions are activated when I mention these learnings. So we're learning from these technology, digital tools, that the learning from the first time is connected to an emotion, and that is put in your brain. So whenever you think of that learning, that emotion comes forward. And let's just say it's a negative emotion, maybe learning geometry. If you have another teacher or you learn along the way a more positive, it can transplant that negative emotion and becomes positive. So making something novel or creative, making it an emotional charge, but then the most powerful of all is useful. We remember things that are useful, not useful to the state tech standards, not useful to our teacher, useful to us. So some way we have to make a point for the students to make the information meaningful, and that will help them remember it longer. So neuroscience principle number 5, brain-informed teaching practices or impactful teaching practices. And it's not a formula. The way that authors put it is, what is the best way to teach this content so that these students have the best chance of learning it? And there comes our expertise as instructors and educators. The public has no idea. They think we just stand up and talk, but it is so fine-tuned for what is the best way to teach this content so that these students have the best chance of learning it. Now, I said I was going to get back to learning styles. So what we are learning about learning styles is that we do not just teach a visual to those that are visual learners or auditory to those that used to be called auditory learners, but that when the brain processes something, it doesn't just take it in one little scoop. So let me just hold up my cell phone for a moment. I'll just turn it on there so you can see my cell phone. So the brain, when you see this, doesn't just take in and kind of make a picture of the object in your brain. It pulls it all apart. Maybe the color is processed in one part of the brain. Maybe if there's words in another part of the brain, if there's sound in another part of the brain, if I have a message from my husband, another part of the brain. So all these things are processed, they take it apart. So what we're doing then when we teach in a variety of ways is we're allowing us to access more of the memory, making it sticky more easily because it's processed in more parts of the brain. It's like if you have an important file on your computer, you might rename it and put it in several folders so that when you're looking for it again, you can find it. So that's the principle of learning styles. The more powerfully way we teach it in different ways, the more opportunities students have to pull it back. So collaboration helps. It's different from listening to the teacher. You're listening to your peers. And I have to say this in a very slow manner because it's a little technical. So I'll get back there. Get back there. So researchers have found out that when people collaborate, the medial orbitofrontal cortex and the frontoparietal network are activated, the latter of which aids in the development of executive functions. So collaboration itself activates parts of our brain that just listening does not. And they refer to these different brain areas as the social brain. So when we collaborate, our brains are charged with the complex task of not just hearing, but making sense of others' thinking and learning to interact. So it's very, very powerful. The big news in the assessment front is formative assessment. If you're an educator, I know you know what's going on in formative assessments. We used to have assessments just at the end, the summative or final assessments. And frankly, then if the students didn't do well, it was on them. It was their fault. They didn't listen. They didn't try hard enough. And we ended up as educators having to make a lot of check marks, a lot of wrong. In my day, it was in red until we learned differently. And so what we're learning about formative assessments is that students often don't even know you're doing an assessment. You're walking around, even a discussion in your classroom. If you have a clipboard, you have your class list, and you just have a little code, a little dot if they've got it. Do you think they've mastered it? Maybe a line if you're not so sure. And you're walking around and you're having the same discussion. You're calling on students in the same way, but you're just making some mental notes and then going back to those students. It's an opportunity, maybe one-on-one, maybe in some small groups. You pull some small groups for formative assessments. Everybody knows, of course, thumbs up and thumbs down, and I'm not sure in the middle. I've seen teachers have those very private so that students don't have to tell everybody that they're not sure of the information. But my very favorite are whiteboards. You just hold those up. And I bought group whiteboards, large whiteboards. And I saw them in a classroom when I did some supervision of student teachers. And I said, I want those because A, it saves a tree, but the students can all work together on a whiteboard. And then you can put those around the room. You can do a gallery walk. So formative assessments have a powerful effect on learning, because right away in the moment, you can do a reteach, you can correct a misunderstanding. But even in the alternative assessment area, games, when students are playing games, it used to be just what you did when it rained. But no, you can walk around in the same manner and watch students playing games, and the game can be their summative assessment. They can put on a play and having to pull in all the aspects of what they have just learned. And again, with portfolios. So these summative assessments are also changing. Yes, we're still going to have some true false, some multiple choice, but we're kind of pulling those down in favor of some of these more alternative summative assessments. And choice, giving students a variety of ways. I have learned from many of you, and again, it's wonderful to see your names and your faces here, different ways that you do these things in your classroom, and have grown myself from what you are doing vis-a-vis these works. So homework and practice, I pulled this little cartoon. So from the internet, Bill missed the rehearsal. So I don't know if you can see this. I have to move my gallery of you all. So instead of throwing his hat at graduation, Bill threw his robe, his graduation robe. So this is showing what just a funny way. Let me get you back again. I've got to move my thing so that I can see this. So it's a funny way of kind of talking about how important rehearsal is to learning. And pull this up here. Okay, there we go. How important rehearsal is to learning. And if homework can be a way for students to rehearse what they learned in a more novel way, it has a high, it shows that the research shows that homework makes a difference. However, if homework is just, quote, dull, boring, finishing your work from school that you should have gotten done during study period or in class, it has zero effect on learning. And it's kind of like, oh my goodness, it's a holdover for many, many years. Parents certainly are a factor in wanting homework. And so we have to educate our parents into what constitutes quality homework, and even giving kids some choices in different kinds of homework, and then certainly pulling it down. A little bit about me: I have an adult son on the autism spectrum. His from when he was in school, his writing was very labored and difficult, and so it took him a long time, even though he has photographic memory and can memorize things very, very quickly. Homework took him a long time, so we had nights of like 3 and 4 and 5 hours, because of course I'm a teacher and my child would finish their homework. And so I need to caution you all, and the authors did of our wonderful text did, on rethinking homework into this applying brain research for our next generation students. So I am going to kind of end the way I began, that this is all there is to know about the brain. So we really have a journey. If you're at the beginning of your career or the middle of your career, or like I am at the end of my career, this is exciting. There's so much more to learn about the brain, because this is still where we are. And this was my ending until about an hour before this talk today. I got an email from one of you in this audience today. And let me give you a little bit of the backstory. At the end of our course, I have all of the students create a PowerPoint, a presentation of what they learned about the brain, certainly for their own review practice, but to give to a real audience, hopefully to maybe their students, telling them about their powerful brain, to their colleagues, or maybe parents. And so today I got an email from one of you, and I will read it. I used my final project slideshow with my students and taught a mini unit at the beginning of the school year on brain-based learning. My 11th grade students responded so well. So these are big, cool juniors who aren't really moved by anything. So I was tickled to really hear this. They were able to make connections to their learning and even discuss what they learned with their parents. Can you believe that? 11th graders talking to their parents about something they learned in school. I shared some of it with their parents on back to school night, and they were very impressed with their students, what their child was learning about how to learn better. So thank you to the person in the audience who shared this with me. And that's why I asked your permission to share that. So I thank you all, and you are on your own brain learning journey. I'm going to come back to you and pass it on to my colleagues, but thank you.